Good morning, my dear friends. See now, we shall pass on to the another loss, which we call it as loss due to shrinkage of concrete. Okay, loss due to shrinkage of this is the another loss, and this takes place in precious concrete embers. Okay, so now as you know, the concrete when it in sense of when you pour it in the formwork. Okay, and in sense now evaporation of the water takes place as the time pass. Okay, so because of this and because of some more chemical changes, what happens is now you have already studied in your concrete technology that this cement concrete will try to shrink a little bit. Okay, sir, now it will try to shrink. Suppose now I have a beam of say now 10 meter span, say now. Okay, assume that this is the beam of 10-meter span now. Okay, so now after some days, say take for example after say some after the shrinkage has taken place. Okay, this beam will not remain 10-meter in the span. No. Okay, it may become little less. Okay, that is how we say that this beam tries to shrink because of the chemical changes and because of the water evaporation, etc., etc. Okay, so now whenever the this thing shrinks, whenever the beam or concrete shrinks, now the steel cable whichever has been now tensioned inside, sir, now that also will shrink along with the concrete, as you know. So now that is how this cable will start losing its length because of the shrinkage of concrete. That is how, okay, the some loss of pre-stress will take place in concrete. Okay, sir, now in your PSC beam, shrinkage loss will take place because the cable start losing its length. Okay, sir, now because of the shrinkage of concrete. So now according to your IS code, okay, sir, now now as I have already said you, we are going to use a code called IS 1343. Okay, sir, now according to IS 1343, okay, the loss due to shrinkage of concrete is given by epsilon sh into es, where es is your it is your Young's modulus of steel. Okay, whereas epsilon sh is baba, it is called shrinkage strain. Okay, it is called shrinkage strain. Okay, sir, now and this epsilon sh according to your is code, okay, sir, now it says that for pre-tensioned beams, okay, total residual shrinkage strain can be taken as 3 into 10 to the power of minus 4. Okay, this is what you have to take it in pre-tensioning beams. If it is post tensioned beams, now this epsilon sh, or it is total residual shrinkage strain, can be calculated by one equation, 2 into 10 to the power of minus 4 in divided by log t plus 2 to the base of 10, where t is it is the age of concrete when you are going to transfer the pre-stress. Okay, no? It is the age of concrete when you transfer the pre-stress. So now by this simple formula, okay, whichever you see here, okay, I can calculate easily the loss due to shrinkage. Okay, so now we will demonstrate it by one example. We'll try to see now. See now, the problem is now, I will read now. A concrete beam is pre-stressed by a cable carrying an initial pre-stressing force of 300 kilonewton. Okay, 300 kilonewton is the pre-stressing force. The cross-sectional area of wires in the cable is 300 mm square. In sense, he has given the area of the steel or the cable. Calculate the percentage loss of pre-stress in the cable only due to shrinkage of concrete using IS 1343 recommendations. Okay, assuming the beam to be, first one A, it is pretensioned, assuming that it is pretensioned. In the second case B, assume that it is post tensioned. Okay, he has given assume ES, in the sense Young's modulus of steel is 210 kilonewton per mm square, or it can be written as 210,000 Newton per mm square. and the age of concrete at transfer of pre-stress is 8 days. Okay, so now we'll see now how it can be now solved. But now initial stress in wires is, okay, as you know, it is force by area. Force, the initial pressing force is now 300 kilonewton. As you see, 300 kilonewton is the force. To convert it into newton into 1000 divided by area of steel. Area of steel is also now 300. So Fs by As will give me the force, the initial pressing force. So it is stress it will give me. Okay, force by area will give me the initial pre-stress in the wires. So it is 1000 Newton per mm square. So now I will take up the case if the beam is pre-tensioned. Baba, according to IS 1343, if the beam is pre-tensioned, then your IS code has said total residual shrinkage strain epsilon SH can be taken as 3 into 10 to the power of minus 4. Okay, sir, now? So, but now also it says that loss due to shrinkage can be written as epsilon SH into ES. Baba, epsilon SH, you know, for the pre-tension beams it is so much. ES, Young's modulus of steel, you know, it is so much. So, but now the loss works out to be 63 Newton per mm square. Or if you want to convert it into percentage loss, okay, sir, no, it is 63 is the loss. This takes place when you apply a pre-stress of 1000, okay, into 100. So 6.3 percentage. Okay. So now we shall go to the B. If the beam is post-tensioned. But now if the beam is post-tensioned, then epsilon SH can be calculated as 2.0 into 10 to the power of minus 4 divided by log T plus 2 to the base 10. Okay. So 2.0 as it is I am keeping here. But now T is, it is the age of concrete at the time of transfer of pre-stress. As you see in the example, he has given age of concrete at transfer is 8 days. Okay. So log T plus 2 is here. 8 I have kept instead of T. Okay. Plus 2 log to the base 10. So if you calculate this, epsilon SH works out to be so much. Okay. So now loss of pre-stress due to shrinkage is now given by epsilon SH into ES. So epsilon SH is here. ES, you know. So now 42 Newton per mm square is the loss of pre-stress. So if you want to convert it into percentage loss of pre-stress, it is 42 divided by 1000 into 100. So it will give me 4.2 percentage. So now this is how very, very simple calculation is there now. By using this simple equation, I can easily calculate the loss of pre-stress. See now, again it is now strain into Young's modulus of steel. Strain into Young's modulus will give me the stress, because again it is a Hooke's law. Hooke's law is stress by strain is equal to Young's modulus. So now if you cross multiply, Young's modulus into strain will give me the stress. So by using this simple equation, I can easily calculate these things now. So now this equation you need not remember, in the sense now it is given on page number say now this. Okay, you need not remember these values also now. Okay, this total shrinkage strain in the pre-tensioning and post-tensioning, it is given on page number 16. As you know, we are going to use IS 1343. Okay, IS 1343 I will show you once. This is your IS 1343. Oh, sir, now IS 1343 1980 it is 1980. Okay, so it is Indian Standard Code of Practice for pre-stress concrete. Okay, on this, if you turn page number 16, oh sir, no, page number 16 is now here. So the equations are now here now. For pre-tensioning it is so much, and for post-tensioning it is so much. Okay, equations are now here. So by seeing this, you can easily calculate the shrinkage loss. Okay, thank you very much.